So the topic is that for discussion it is Thevenin'S theorem. Thevenin'S theorem is a theorem used for simplification of complex circuits. Simplification of complex circuits, it's done through Thevenin'S theorem. But here we will be illustrating it with a simple example. Let me draw a circuit having a voltage source V and three resistances. So these are those three resistances. Let us name those three resistances as R1, R2 and R3. So I am naming the circuit as A, B, C, D, E, F. Now, through Thevenin'S theorem, we find out the current flowing through a particular circuit. Here, let's assume that the current we should find out through R3. हम लोगों को R3 से current निकालना होगा. Let us assume. So, assuming this, there are certain steps to be followed for making this possible. So, step 1. What is the step 1? The first step is we should open this terminal CD. So, open the terminal CD. So, if we open the terminal CD, the circuit will somewhat look like this. Next, step 2. Across this open circuited terminal, we will evaluate a voltage which is called the open circuit voltage or the Thevenin'S voltage. Across this open circuited terminal, we will compute the value of VTH, that is the Thevenin'S voltage, or in other words, it's called the open circuit voltage. So, what will be the value of this open circuit voltage? This open circuit voltage, it will be the same voltage across the terminal VE. So, what it will be? V into R2 by R1 plus R2. This is according to the voltage divider rule. This is according to the voltage divider rule. Then, this was the step 2. Now, in step 3, we have to find out the equivalent resistance flowing in the circuit when this C and D is open circuited. When this C and D is open circuited, we have to find out the equivalent resistance flowing through the circuit. And how will we find out this? We will find out this from this area, the equivalent resistance. But before finding out the equivalent resistance, there is a process that when a voltage source is connected, we have to replace the voltage source with its internal resistance. And when we replace the voltage source by its internal resistance, then we short the terminal. If it was a current source, we would have opened the terminal. But since it is a voltage source, we have shorted the terminal. So here, R equivalent is equal to, it will be like R1 parallel R2, which is R1 into R2 by R1 plus R2. And this R equivalent, in other words, it is also called the Thevenin'S resistance. The final step that is step 4, is to draw the Thevenin's equivalent circuit. Now, in drawing this Thevenin's equivalent circuit, we will again place the load resistance at its own place, that CD. The load resistance will again be placed here, R3, this was the load resistance, and along with it, the Thevenin's resistance will be there and the Thevenin's voltage will be there. So this is the Thevenin's equivalent circuit. Now we will find out the current flowing through this circuit. It is a series circuit where two resistances are there in series. One is RTH and one is the load resistance R3. The final step, that is step 5, to find out the load current, that is IL. Why it is load current? Because the current is flowing through this R3, where R3 is the load resistance. So it will be a simple one like VTH by RTH plus R3. This is the final value of the load current that is computed from this circuit. Thank you.